Welcome to the next video on abstract linear algebra. This is video 7. We'll be discussing the basic properties of zero and inverses. This corresponds to chapter 1, section B of the textbook. So the first theorem is that zero annihilates, and what I mean by that is this claim right here, that if you take any vector from your vector space, and right, the background here is that V is going to be a vector space over some scalar field denoted F, and it's going to have a plus and a times and so on, right? So all of that is going to be kind of boilerplate from now on. And so with all of that in the background, if you take a vector from your vector space and multiply by the scalar 0, you always get the vector 0, so that effectively multiplying by the scalar 0 annihilates any vector. So how are we going to prove this? Well, let's start by writing down the left-hand side and see if we can't, show that it's equal through a chain of equations that eventually arrives at the vector 0. Now we have to use some sort of property of 0 here, and its main property is that if you add it to something, it doesn't change. Well, what would that other thing be for us right now? Nothing particularly stands out, but since nothing else seems relevant, then maybe what we would do is use it with another 0. Right, so that's using the distinctive feature of 0, which must be relevant here. It's the additive identity. And we're using the fact that 0 plus 0 is equal to 0, which certainly is valid due to the, additive identity property. So this is a valid move. It makes use of the distinctive property. Perhaps it's going in a good direction. We'll see. Let's keep going. Okay, from here, the natural thing to think to do is to distribute and from here, what we notice is, well, there's a 0v here and also a 0v here. I mean, also here, but the point is that now that I see all these 0v's all over the place, I could subtract it from both sides. So from all of this, I can infer that if I subtract 0v from both sides, then my left-hand side is this, and my right-hand side is this. And this side naturally just computes to 0, because, right, it is a vector together with its inverse, and so it must simplify to the 0 vector. And on the right-hand side, we could put those two together. They simplify to the 0 vector. From here, we can use the additive identity property of the 0 vector to say that that's just 0v. And this is exactly the claim that we wanted to demonstrate, so the proof is complete. Okay, let's see another theorem, and this one says that the vector 0 annihilates. So this kind of says it the other way around, but you get a similar result. If you take any field element, any scalar, and you multiply times the 0 vector, you always get the 0 vector. So how are we going to prove this one? Again, it seems like, maybe we'll start from writing down a times the 0 vector. And maybe, again, we'll use the additive identity property of the 0 vector, so we'll call that 0 vector plus 0 vector. We'll distribute a 0 plus a 0. We'll subtract from both sides, and this now gets us on the left-hand side the 0 vector equals on the right-hand side it simplifies to a times the 0 vector, and again, proof is complete. And for the final claim of this video, we will show that multiplying by -1 inverts a vector. That is to say, if you take any vector, its inverse, its additive inverse, which, recall the definition there, the additive inverse is by definition the thing where if you add v, you get 0. right? That's the definition. We're going to show that it's the same thing if you multiply by -1. Okay, so how are we going to prove this? Well, let's use the fact that we've already shown that inverses are unique. We're actually going to use that earlier theorem from the previous video and say that, well, since inverses are unique, what I can do is show that this thing on the right-hand side has the inverse property. Namely, I just want to show, so maybe I'm going to annotate this by saying, want to show the following. If we take -1 times v plus v, I want to show that that's equal to the 0 vector. This would mean, right, if I show this, it shows that -1 times v has the inverse property. This is the inverse property. If it has the inverse property, it must equal the inverse of v by that uniqueness theorem previously, right? So that's my strategy here. I'm going to show that -1v has the inverse property. So if we take -1 times v and we add v, what can we say about that? Well, it seems natural that we would try to factor, right? Both terms have a v in them. Let me go ahead and write the other one with an explicit scalar on the front of it, basically, so that now it becomes very explicit what is going on when I factor. When I factor, I get -1 there, I get 1 there, and v factored to the outside. This is using distribution in reverse, by the way, so although I'm calling it factorization, when you use distribution in this direction, that's just the same thing as factoring. But in any case, now here we can use knowledge of the field, right? We've got -1 plus 1, and we know that in any field that's always equal to 0. And we just proved a moment ago that this is the same thing as the 0 vector. And that concludes the proof, basically. If you appreciated this content, please like and subscribe. And if there's anything that we discussed here where you'd like to see it elaborated further, I might be able to answer questions in the comments, or for substantial topics, I might make an entire video and add it to the playlist.